Welcome to our introduction to MIDI. MIDI is an incredibly powerful and flexible tool for your music production. Before you start using it, you should know exactly what it is and does. MIDI recording's different than audio recording. A MIDI file contains performance data but no sound. It's kind of like a player piano. While the piano's making the actual tone, the song is coded in the piano roll. If you took out that roll, it would just be a roll of paper, not a song. If you put the roll in another player piano, you'd hear the unique tone of that new piano. The piano roll controls the instrument, but it's not the instrument or the sound itself. MIDI's digital language is like the piano roll, except the MIDI messages are way more complicated and sophisticated. Let's take a quick look at where MIDI came from. MIDI came on the scene in the early 80s. It was the brainchild of a group of synthesizer manufacturers. At the time, it was hard to connect different brands of synthesizers together. One synth might have good strings, but then you couldn't connect it to your favorite synth that had good horns. So, the manufacturers decided to work together to develop a universally standard language for sharing data between different brands of synths. This language was called MIDI. It stands for Musical Instrument Digital Interface. The first synths came out with MIDI in '83. After that, you could sit at one keyboard, which was connected to a few others of different makes and models, and then trigger them all from your one keyboard. It really simplified live performances that used MIDI sounds. Instead of a bunch of synths on stage, you could just hide them under the stage. You'd control them from one master on the stage. After this time, people realized they didn't need a keyboard on every synth. So the synth module was born. Well, this paved the way for the development of the MIDI controller, which was smaller and cheaper and lighter than a keyboard synth. A MIDI controller can trigger a whole bunch of synth modules, and they're easy to transport. It didn't take long for MIDI musicians/engineers to push for the next development. MIDI sequencers came next. MIDI sequencers are hardware devices designed to be connected to a MIDI controller, capture MIDI data as the musician plays it, and then store the data for playback and modification. One of the main reasons that MIDI music recording was so exciting is because you could record something at a slower speed and play it back faster. So if you weren't a virtuoso on the keyboard, this was a huge plus. In addition, you could transpose keys and edit individual notes. When the PC revolution got underway, it was a perfect match to nurture the development of MIDI software sequencers and virtual instruments, where incredibly high-quality instrument sounds live in a software plugin. On the market today, you can find an impressive variety of world instruments, all recorded at a very high sample rate. Motu's virtual instrument products are some of my favorites. Okay, let's talk about how MIDI technology works. MIDI data is transmitted through a MIDI cable that has 5 connectors and looks something like this. Let's talk about what each of these connections do. Pin number 1 isn't actually being used. It was once thought that this pin might be used for some future improvement, but this hasn't happened. Pin number 2 shields the MIDI cable. It prevents electromagnetic interference from disrupting the MIDI data. Pin number 3 is also not being used. Pin number 4 provides the grounding needed by the system. Pin number 5 is the one that carries the data. Because MIDI data is serial data, meaning that the data events get transmitted one after another, not at the same time. So basically all you need for data transfer is a single connection, but you need a cable for each direction, in and out. One to send information and one to receive it. Because one MIDI cable can only transmit data from one device to another, most MIDI gear have 2, if not 3 ports. Most MIDI instruments and sound cards these days have a MIDI interface that looks like this. The MIDI in port brings data in from somewhere else, like from your keyboard into your sound card. It lets your keyboard control your sound card. The MIDI out port allows the device to be the controller, like from your sound card back to your piano. This is how you play back recorded MIDI data through your synthesizer. Your sound card would be sending messages to and controlling your electric piano. The MIDI through port sends a copy of the data received at the MIDI in port to another MIDI device in a MIDI chain. It doesn't control anything, it's just a connector. Now let's take a look at how MIDI does its job, that is, how it controls devices and expresses musical ideas. MIDI has 2 kinds of messages, channel messages and system messages. System messages are related to the MIDI hardware and technical issues. They don't trigger sounds, but they help make sure that the sounds coming from the various parts of your setup are synchronized and that the devices are properly connected. Channel messages communicate the performance data like volume, pitch, or velocity and frequency, and other digitized renditions of musical expressiveness. This data works kind of like the role in a player piano. First, there's a message telling the note that it has to go on. Each pitch on the keyboard is assigned a number. How hard you press the key is also assigned a number on a scale between 1 and 127. 0 is soft, and 127 is loud. There's a lot of other data that goes into this message, all the complexity of musical expressiveness somehow quantified into zeros and ones and code. Panning, phrasing, instrument type, MIDI sends all of this data in a long string. When to stop playing, how fast or slowly you stop playing, etc. Now, how does MIDI know which sound to play? In the olden days, you got different sounds from a synth by connecting its various components in different ways with cables. That was called patching a sound, and the cables were called patch cables. You'll still hear people using these terms today. Different sounds also became called patches. Sometimes you'll hear them called programs today. Each patch or program is assigned a number, and the MIDI channel message shares this info also. This isn't consistent across all synths, but many brands and models today do use what's called general MIDI, a cross-manufacturer default order of sounds. That's why you tend to find the pianos and organs at the bottom of your program bank, then guitars and strings and horns, etc. Many synthesizers today use these numbered patch standards. And this concludes our overview of MIDI basics.